I'm going to focus on projects that involve both a hardware and a software component, and talk about Agile in those types of products and projects. So I didn't know who my audience was going to be, so I have a little bit of an intro on Agile. And why to use Agile, and then can embedded development be Agile, and finally how. So how many of you are familiar with Agile? Okay, so everyone. So I could just run through these real quick. Okay, so the manifesto you're all familiar with. The 4 values, always value individuals and interactions over processes and tools. Working software, in our case, working product over comprehensive documentation. That's true in some environments, not in all. Customer collaboration over contract negotiation. In other words, I'm going to listen to my customer rather than trying to push back on my product owner in terms of what it is that I can deliver. Because ultimately it's about the customer. Finally, responding to change over following a plan. And that's probably the key. There are 12 principles of Agile. I'm not going to read them off. But face-to-face, as we all know, is the most effective form of communication. So that's an important one. Working prototypes equals progress. Satisfying the customer. Simplicity and self-organizing teams. Agile according to Dilbert. So we've got something called Agile programming. It's great. It means that we don't have to do documentation. Great. It has a name. And I'm going to focus on Scrum, which is an Agile methodology. It was developed by these 2 guys, Jeff Sutherland and Ken Schreiber. Probably mispronounced his name. And this illustrates the Scrum framework. So the important thing to note here is that you have a Scrum team, and even when you're developing with the embedded system, you're going to have Scrum teams that are associated with the different roles that you need for that embedded system. And the typical software Scrum sprint size or length is 2 weeks typically. But sometimes hardware scrums require a little bit more time. I've heard hardware teams using 1 week sprint times, and I've heard hardware teams using 4-week sprint times. So it really depends on what it is that you're trying to build and on the receptiveness of your team. Okay, so why use Scrum? Well, according to Forbes, the top 10 IPO companies were Scrum companies. And John Deere, as an example, was able to increase their velocity by 820% in manufacturing using Scrum teams. And it's not just for software. So you've got these different companies using Scrum to develop programming, develop actual hardware machines, fighter jets, marketing, even winemaking. And GE used Scrum teams to transition their company from 20th century thinking into the 21st century, and that was more of a branding, marketing, internal project. What are the benefits of Scrum? Well, the idea is to maximize your return on investment while minimizing the risk. So this company called, there are a number of companies that do Agile and Scrum surveys. This particular one that I pulled recently is from a company called Version 1. This is their 11th annual State of Agile report. And they got thousands of people, including they had about 20% of survey results from their customers, and about 80% from the entire Scrum and Agile ecosystem. And they found that 88% said that the top benefit of adopting Agile was the ability to manage changing priorities. The next one was project visibility, which is a huge one when you're dealing with embedded systems. Increased team productivity, the delivery and speed, time to market, team morale, business IT alignment, software quality, project predictability, and on and on and on, okay? So why don't we use Agile in embedded development? Well, so here's another wisdom by Dilbert. Well, we're different. We have constraints, right? Hardware isn't always ready. You've got small memory constraints, so you're trying to develop for a defibrillator or a pacemaker or a, I don't know, Roomba vacuum or some other kind of embedded system, and you're limited with memory. Your prototypes are limited at the start of the development process. You don't have enough to go around. You have to develop on the target, because if it's off the target, well, it's meaningless. You have to test on the target, because unless you test on the target, you don't know if it really works, and on and on and on. So, and teams have tried Agile, and what do they say? Well, it didn't work. Okay, so then you start digging into what they really are telling you that they've tried. So do you do 2-week sprints? No. Do you do test-driven development? Well, that's impossible in embedded development, right? So no. Do you have automated unit testing? Again, impossible in embedded systems, right? So no, we didn't do that. Do you have a release plan? Yeah, it's a 2-year release plan. Okay. Do you do pair engineer? What? Do you do what? No, we didn't do that. Do you refactor code? Well, we don't plan for refactoring. We don't have time in the schedule to refactor. Do you involve your customer? Sure. Yeah, the marketing guys go and talk to the customer at the beginning of the project, and we have a set of requirements that we start at the beginning of the project, and then, about a year into it, we show it to our marketing guys. They come down, and yeah, we involve our customers. Of course we do. Do you write stories? What are stories? What do you mean by stories? We have requirements. They each have a number. Okay. And do you do continuous integration? Well, we can't do automated testing, so how are we going to do continuous integration, right? Okay, well, what did you do? Well, we wrote less documentation. Well, that's great, okay? Well, it is extreme in the sense of extreme programming, but it is not extremely good. So, to give an example, Saab developed a fighter jet using Scrum teams. So if Saab can do it with a fighter jet, why can't you do it with a Roomba or a smart scale or a defibrillator or a pacemaker or a monitoring system or anything else that you might be building, or a guitar amplifier? Well, there are challenges. It's true, right? So you want to address the challenges right up front. Okay, hardware does require documentation. It requires schematics, layouts, Gerber files. You have to do fabrication and so on. So you have to source the parts. You rely on third-party test houses to do your compliance testing, to do your fabrication. Molds, plastic molds. Well, you can't build plastic molds in 2 weeks, can you? I heard that there was somebody here who has a 3D printing business.
It's a subtractive process, but close enough.
Close enough. Okay, good. Good. So what does work? Well, okay. So in companies who have been successful using Scrum in embedded systems have done two things. First of all, well, more than two things, but the first thing that you need to do is understand what it is that you're building and understand it well. So yes, you do have to take the time up front to think about your system and what you're trying to build. And once you've done that, then you need to define what the critical requirements are. Without these requirements, this product is going to fail. It's not going to work. Okay? Those are your starting points. And then you work around those. So let's say you're building a drone or a HD camera or anything else. You need to understand your market. You need to understand the regulatory requirements. You need to understand the constraints, how the user is going to interact with it, and will it be connected. And then you come up with a concept. You list your high-level crucial requirements, and you plan for those up front, because those are the things that you need to make sure, you need to test those and work on those to reduce your product risk. So those are going to be planned as one of your first sprints. You need to find other ways to learn fast, fail fast, okay? So modularity. One of the things that that we learned from the WikiSpeed. Does anybody know about the WikiSpeed Roadster? Okay, there was a team. They started the project back in, I believe it was 2009 or 10. It was a group of engineers who decided that they were going to build a car, and they were going to build the car using Scrum teams. And if you want to Google it, Joe Justice, it's very, very interesting to look at the history of this car. They came up with a concept. And notice how modular it is, okay? And the first iteration was a chassis. Okay, the first product was a chassis. And they were aiming for these requirements. Within 3 months, they had a working prototype. 3 months, a working prototype of a car. Now, no, it didn't have an engine yet. It didn't have anything beyond a chassis and suspension, but it was a pushable car. And shippable doesn't, okay, so when we talk about getting to the end of a sprint, we talk about something that is shippable, right? So with software, it's something that we can write and we can demo and we can give to our customer, and it'll meet their intended requirements for what it is that we were able to put into the sprint, and we build upon that, and the next sprint they get another shippable version of the software and so on and so forth, right? Well, in hardware, it's the same thing. So, but shippable doesn't mean that it's pretty. It doesn't mean that it's what you're going to end up necessarily selling, but it does mean working. Okay? So you can see this car right here. It's got suspension, it's got steering, it's got a cabin, it's got its batteries sitting on the outside of the chassis, but it's running. So it's working, it's shippable. You can demo it, you can test your assumptions, you can test your critical features, you can reduce your risk. This was, by the way, this is the first Apple computer. So this is another way of building your prototypes. You breadboard it, right? So you don't need to fabricate your own PCB board or PCBA to start writing embedded code and start testing and working through your assumptions. You can do that with prototypes, especially in today's world. This was the first iPhone. This is a wearable. Okay, so I'm going to walk through the example of building an amplifier. How much time do I have? Do I have enough time? Okay, good. I'm going to walk through the example of building an amplifier. These are the critical requirements. The amplifier has to meet these requirements or we can't sell it. Okay? This is the high-level process. So you have to build your schematics, but do you have to do that off the bat? But what I wanted to mention here is that you can buy off-the-shelf embedded development boards. And you can not kludge, but you can put together those components that are most critical for your system, and you can start writing embedded code, and you can develop your test environment, and you can have test-driven development with a development board. So ST has them, TI has them. You can use an Arduino if you need to start. With molding, you can use 3D printing. So you can for all what you really want to do is you want to figure out what the size is, right? So you can cut out a cardboard box. I've seen people use plexiglass and just develop their model system on plexiglass. And so the $15 ST Micro development board that you're going to buy is not an expensive prototype. Every single one of your engineers can have one of those development boards. It's true you do need to develop documentation. Okay, but I'm gonna go on a limb here and say that while your embedded developer is writing code to that development board, your hardware engineer can, in parallel, be developing a schematic as part of that sprint. And at the end of that sprint is a deliverable schematic. And working means that it was reviewed. And done means that it's signed off. And so if that's your 2-week sprint, that's the deliverable at the end of that sprint. Post-it notes. I love Post-it notes. So yes, Matt was mentioning how he got rid of Jira. I love Jira. Okay, I'm never. I am a believer. I've drank the Kool-Aid, but it's not visible. Okay, Post-it notes on a whiteboard or on a window, or taking, markers and marking up the window. That's visible. Everybody walking by sees it. It's in your immediate consciousness. You can move things around easily. You can't do that as easily in Jira. Okay, especially if you're working with mob programming and you've got your one computer and you're typing on your one computer. Plan your teams. Okay, so Matt talked about different skill sets that he needed on his teams. This is an actual organization in a company, in a consulting company that uses Scrum teams for their embedded development. And so they have the different teams and the different members of a team based on their skill set. And you might have multiple teams running in parallel, but if you have multiple Scrum teams, you always do a Scrum of Scrums. So you're always focusing on the communication. I agree with Matt that 100% the most important thing is to maintain that communication. Organize your sprints. Okay, so no part of the organization is going to be, especially in embedded software and embedded systems, you need to look ahead a little bit to know when you will have certain prototypes available to try. And part of that is because you are relying on third-party vendors to provide you with to take into testing. But one of the things that I didn't talk about is how do you reduce the risk when you're talking about compliance testing? How do you not fail your EMC testing or EMI testing? And just like any other tool set that you would buy, that you would purchase to have in-house in your lab, those should be part of your of the tools that you have in your lab. So you run those tests in a continuous fashion. So you make a change, you build your prototype, you test it. Your prototype may not be ready for test, and that's why it's important to build your sprints. But once your prototype is ready for those types of tests, you test it and you continuously test it, so that you don't get to the lab, you don't get to TUV or NEMCO and fail your test because you neglected to test it in-house. Does that make sense? Okay, we talked about sourcing off-the-shelf components. This is actually this is an amplifier that's kind of put together. Thank you. This is actually a TI example product where you can buy their board off the shelf. If you happen to be building an amplifier, then you could buy it off the shelf and use theirs, and then customize what you need for your product in order to meet your critical requirements. And finally, daily stand-ups. Don't forget those daily stand-ups. Your hardware engineer, your product owner, your embedded team, your test team, your procurement team should all be involved in your stand-ups. They should all be, so whoever is going to be your bottleneck should be part of that Scrum team. Test-driven development, burn-down charts. So Matt talked a little bit about estimating and why he doesn't do it anymore. It's true that we can fool ourselves into thinking that our numbers are good when actually we could be doing better. But it's always about that trying to do better, always about doing that retrospective and questioning yourself. So it's about having trust in the team to do the right thing and to continuously improve. So it's all about the people. Listen to your customer. Foster talented teams. Manage the change. That's always critical. So you have an organization who's been doing waterfall development for years, and now you're saying, okay, well, we're going to go to Scrum. How do you manage that change? That's a tough one, right? And you can't just not tell them. You can't just start doing mob programming. Scrum really requires an organizational mindset. And iterate. Always be iterating. So, briefly defined Agile, we reviewed the benefits and gave examples of Scrum projects, including that fighter jet. Walk through the Scrum implementation, and now I have some time for questions.